This video is going to walk you through the solutions for the worksheet, the first worksheet on section 4.5. So first of all, the first problem asks us to calculate the molarity of a solution if we're given the solute in grams and the volume of the solution. This is a pretty straightforward problem. Our first step is to figure out the moles of our solute, Ki. We're going to do that by calculating the molecular weight of Ki, doing a unit conversion. Once we get the number of moles of Ki, we'll plug that into the molarity equation. Remember, molarity is moles divided by the volume in liters, has to be in liters. So we're taking that milliliters and dividing it by 1,000, and we get 0.261 molar Ki. Second problem is pretty much exactly the same. We have 1.77 grams of CH3COOH. So our first step is to convert that into moles using the molecular weight of CH3COOH. Once we know how many moles we have, we're going to plug that into the equation for molarity, dividing by the volume in liters, and we get 0.347 molar CH3COOH. This next problem is a little bit trickier. In this one, we're being asked to figure out the volume of a solution with the molarity that's provided, knowing that we want 3.81 grams of C6H12O6. So anytime you're doing molarity calculations and you're given the mass of the solute in grams, first thing that you should always do is convert that into moles. So here I'm taking the mass, 3.81 grams, using the molecular weight, figuring out how many moles we have. Now, the rest of this problem, we are going to use the molarity of the solution, 2.53 molar, as a conversion factor. And so 2.53 molar means that we have 2.53 moles per 1 liter of solution. And we can use that relationship to convert from moles into liters, which is what this problem is asking us to do. So here we've taken the 0.02117 moles of our solute, and we're using the molarity as a conversion factor to go from moles into liters. This is an upside down molarity, right? Because normally molarity is moles on top of liters. Okay, but here we're using this as the relationship, like I said, between moles and volume. So this allows us to cancel out moles and calculate the volume of the solution in liters. So that's a pretty tricky one. Our next problem is a dilution problem. We have 2.50 liters of 0.4 molar solution, and we're diluting it to 3.25. So we just have to plug into the M1V1 equals M2V2 equation. M1, our initial molarity, is 0.4. V1, our initial volume, is 2.5 liters. M2 is what we're trying to solve for. V2 is 3.25 liters, the volume after dilution. So here we're just going to rearrange for M2, dividing the left side by 3.25, and solve, and we get 0.308 molar KMnO4. The next problem is the same. We have an unknown volume of initial molarity, 8.35 molar, and we're trying to make a final volume of 500 milliliters and a final molarity of 1.75. So again, we're just going to plug into the dilution equation our initial molarity, V1 is what we're trying to solve for, our final molarity after dilution, our final volume after dilution, do some algebra to solve for V1. This next problem is more challenging because we are being asked to do calculations in units of grams, and all of these equations want us to express our solute in terms of moles. So this is asking how many grams of calcium hydroxide do we need to make 100 mils of a 0.10 molar solution. So what we're doing here first is saying, well, I want a solution that has a mole to volume ratio of 0.1. I want to have 0.1 moles of calcium hydroxide per liter of solution. But I don't want to make 1 liter of solution. I want to make 0.1 liters or 100 milliliters. So what we're doing in this first step is canceling out our units of liters and figuring out how many moles we need to have in this smaller volume of solution. So in this step, we are doing a calculation how many moles we need to have, and then we are converting straight from moles into grams of calcium hydroxide using its molecular weight. So this step allows us to cancel these mole units, and what we're left with are the grams of calcium hydroxide. This problem is quite a bit trickier than the other ones